Hey guys, had a question from a couple of you on one of the homework questions on 5.3, and this is question 10 on lesson 5.3. So we're going to take a look at that, and the question asks you to find all the roots of that equation. X cubed plus 64 equals 0. Let me check and make sure that I'm doing the right question and have the right, find all the real and imaginary roots of this thing. So this is, if you look in your notes, this is actually a sum of two cubes. This is something that's different to us or new to us. So I think it's a good idea to take a look at it. So in your notes, you should see that we can factor a sum of two cubes. If we have a cubed plus b cubed, we can factor that thing as a plus b times the quantity a squared minus ab plus b squared. All right, a little bit of a glare on that. I apologize. All right, but that last little bit there is plus b squared. Okay, so what I look at here is, first of all, I got to recognize this is a sum of two cubes. So obviously x cubed is a perfect cube, x times x times x. And then you have to recognize 64 as a perfect cube. So the cube root of 64, you can use your calculator or kind of guess and check. But this is actually 4 cubed. All right, 4 times 4 times 4. So the first thing I'm going to do to help us solve this thing is just rewrite that as 4 cubed. All right. So excuse me. So now I can see that a in this case is x and b is 4. All right. So this is a cubed plus b cubed. All right. So I can factor it just like this. All right. So I can factor it as a plus b, or in our case, x plus 4 times the quantity x squared minus 4x plus 4 squared. All right. So again, all I did was just take our general form for sum of two cubes and just replace a with x and b with 4. All right. So I get this, and again, it still is equal to 0. Let me squeeze that in on the right hand side. All right. Now the other thing that I'm going to do here, and I'm not going to use a whole line for this. I wrote it this way just so you can see it, but 4 squared, I'm actually going to write that as what it is. That's 16. Okay. So now I look to, so we're starting to factor this thing. I've got that factored as a linear, just x to the first power. I can't do much more with that. We'll come back to that later. But here I've got a quadratic. So I should be able to solve that from here. Now again, I want to look and see if I can factor that. Are there factors of, because again, my coefficient here is just 1. So are there factors of 16 that add up to -4? And I can't think of any. All right. So that tells me what we're going to have to do here is the quadratic formula. All right. We do have to solve this with the quadratic formula. So in this case, a is 1, b is -4, and c is 16. All right, so we're going to use the quadratic formula to find the two roots of this. So one of our roots is -4. All right, if x plus 4 is 0, I can solve that one. So in your solution there, you should see one of your solutions as -4. That comes from that right here. The other two solutions are going to come from the quadratic formula that we're about to do. Here. So let me go through the quadratic formula. So the opposite of b, if b is -4, that's +4, plus or minus the square root of b squared. So that's -4 squared minus 4 times a times c. And that whole thing is divided by 2 times a. All right. So now I start doing some order of operations here. So I have 4 plus or minus the square root of -4 squared is 16 minus 4 times 1 times 16 is 64. And then I'm also going to go ahead and do that multiplication there. So that's all over 2. So I got 4 plus or minus the square root of 16 minus 64, all divided by 2. And so now if I do 4 plus or minus 16 minus 64 is -48, all divided by 2. And now I want to see if I can simplify this. So first thing I notice is I'm doing the square root of a negative. So I know I'm going to involve the square root of -1 or an I. And the other thing I want to look for is, does 48 have any perfect square factors? And what's the largest factor? What's the largest perfect square factor of 48? And 48 is actually 16 times 3. All right. So what I'm going to do is I'm going to come off to the right here. So I've got 4 plus or minus I. And then I'm just going to write that as 16 times 3 entirely over 2. And so now I can simplify this even further. The square root of 16 is 4. All right. So what I get is 4 plus or minus 4i times the square root of 3 all over 2. And I'd be perfectly okay if you came up with that answer. All right. 4 plus or minus 4i, radical 3 over 2. But to get it to match with the answer that I had. So again, one of the solutions is -4. The other solution is right here, but I see everything can be divided by a factor of 2. So that's where you see the 2 plus or minus 2i radical 3 over 1. I didn't put the over 1, so that's why in the other answer you would see 2 plus or minus 2i radical 3. All right, so hopefully that helps. Again, just this is the first time we've seen a sum of 2 cubes and then also the difference of 2 cubes. But again, hopefully this helps. It gets you down to this point. And then again, once you get a quadratic, you can factor that. Or in this case, we did have to go with the quadratic formula, but that'll help us find those other 2 roots. All right, hopefully that helps. If you have any other questions on the 5-3 homework, don't hesitate to let me know. Take care, guys.